Hi everybody! So in this video, I'm going to teach you some rules to find the derivative. And so what these rules are used for is when you're given a function, and instead of finding the derivative of one single point, you just want to find an equation that represents the derivative of the entire function. And so in order to find that, you have to follow rules. And so the first rule I'm going to talk about is the power rule. That's supposed to be a U. Okay, well, U-L-E. Okay. So the power rule states that the derivative with respect to x of a function x of n equals n times x to the n minus 1 power. Pretty simple. All right, so let's do an example of it. Let's find the derivative. Ooh, that was ugly. Okay. Find the derivative of f of t equals t cubed minus 12t t plus 4. All right, so this is just simply applying the power rule. So f of t equals, so this is applying the power rule to each term. So the first term, t cubed, will be the exponent 3 times t of 3 minus 1, which is 2. And similarly, for the next term, minus 12t, the exponent here is 1, so it's just 12 times 1, which is 12, times t to the 1 minus 1 minus 1, which is 0, so it's 1. And then the derivative of any constant is 0 because constants don't change, and a derivative is the instantaneous rate of change. So your answer is 3t squared minus 12. Okay. Moving along, we'll do the product rule. Product rule. Okay. So the product rule states if you have two functions, f and g, and they're differentiable, which means they have a derivative, then the derivative of f times g would equal f of x. Oh god, that's ugly. Okay. F of x times the derivative of g of x plus the derivative of f of x times g of x. Yeah. Right, let's do an example. Let's find the derivative. The derivative. The derivative of h of x equals x squared to the 9x plus 4. Okay. So you're given one function, h of x. But if you can tell here, it can be broken up to a product of two functions. So here, I'm going to say h of x equals f of x times g of x. Okay, where f of x equals x squared and g of x equals 9x plus 4. So because it can be broken up into a product of two functions, we could just apply the product rule. So the derivative of h of x equals f of x, which is x squared, times the derivative of g of x. And in order to find the derivative of g of x, you use a power rule, which is just 9. And then we're going to do the derivative of f of x, which is, again, apply the power rule to f of x. That's 2x. I'll put parentheses. Times g of x, which is 9x plus 4. All right, from here, we're just going to simplify it all. So this is 9x squared plus, 18x squared plus 8x. And then that's 27x squared plus 8x. And that's the derivative of h of x. Pretty good, doing good. Okay. Moving along, we will talk about the quotient rule next. How do you spell quotient? Q-U-O-T-I-E-N-T. Okay, rule. Okay. So, again, if you have two functions, f and g, they have to be differentiable. That's how you spell it, right? Oh, yeah. Differentiable. And g of x does not equal 0 because you can't have a 0 in the denominator. Okay, let me zoom out a little. Then, if we have a function where f and g are divided, the derivative of that is g of x times derivative of f of x minus f of x times derivative of g of x all over g of x. I'm just going to put parentheses around it to make it clear. Square. And so this one's a lot more harder to memorize, but there's a cute little trick. It's low, so g of x, d high, the derivative of the top, which is f, minus high, d low, and square the bottom, and away you go. And so that's how I remember it. And so since we have g of x in the denominator, that's why we need this requirement where g of x does not equal 0, because you can't have a 0 in the denominator. Right. So let's do an example of this. What is the derivative of, let's see, let me scroll up a little. H of x equals x all over 1 plus x squared. Okay. So we could break this up into two functions that are being divided. So I'm going to say h of x equals f of x divided by g of x, right? And this is, so then that means my f of x equals x, and my g of x equals 1 plus x squared. Oh, I just realized that kind of looks like a 4. 1 plus x squared. Okay. So now let's just apply the quotient rule. So the derivative of, that looks like an n. Okay. The derivative of h of x equals low, which is 1 plus x squared, d high, so the derivative of f of x, which is just 1, minus high, which is x, d low, the derivative of g of x is 2x, and square the bottom, which is g of x squared, which is 1 plus x squared. Okay. So now you just simplify it. So let's do that. It's 1 plus x squared minus 2x squared all over 1 plus x squared. That could be simplified more. That was an ugly equal sign. Equals 1 minus x squared all over 1 plus x squared. Can it be simplified more? No, that's it. All right, so the derivative of h of x, oh my god, that was ugly. H of x is that. And those are your rules to find the derivative. So quick recap, we have the power rule, which is the derivative of x of n equals n times x to the n minus 1 power. We have the product rule, where if the derivative of f times g equals f times the derivative of g of x plus the derivative of f times g. And the quotient rule, which you can remember as low d high minus high d low, and square the bottom the way you go, which is g of x times the derivative of f of x minus f of x times the derivative of g of x all over g of x squared. And so, there you have it. Thanks for watching.